Next we have here is A3, that is excessive data exposure. Yeah. So what this thing is? So yeah, in this attack now, API exposes a lot more data than what the client legitimately needs. Means if you are accessing one thing, but you are getting way more resources in return, means in response, because the client side filtering is not happening. That's why. So if attacker go directly to the API, so they have it all. So next we have another lab here, that is A3. So I'm sharing my screen again. I'm changing my screen again for that. So for that we have a application here. See, the lab is now going to the application phase. A3, excessive data exposure. So we have an Android app here to check the functionality. So yeah, this is the content of the app. Means here the app is hosted. So see the comment tab. So yeah, now we will use this application, and we will use this application's request. We will intercept this, and we will try to gain access in the application. Yeah. So for that, I have to change my screen again because the application is hosted somewhere else. So see guys, this is nothing but a emulator, Android emulator. So see, this is the app here, that comment app, and we will use this app to check that excessive data exposure thing, that how it is worked and all that thing. So see, I will open this app. Yeah. So yeah, this is the thing. This is the interface of the app. So for that, I have to show you that. No, first of all, I have to paste the base URL here, that where it is low hosted. So that's why I have to give here my Kali Linux IP, because my that means this web application is hosted on Kali Linux Apache 2 web server. So for that, yeah, I'm trying to fetch my IP address here. Now I get it. Okay. Okay. So yeah, so I have to type it for HTTP with the whole URL. Next, vAPI. The next we have here is our user ID and password, and the next functionality we have here is our create account. So yeah, so now we will use this application to intercept with our burp suite. For that, a little setting has to be made again. Okay. Yeah. For that, I have to change my interfaces for the proxy listener from here. So I will just add the one port here, that is 4 sevens, and yeah, to all interfaces. Okay. Now it will listen to this ports only. So it will be good. Now it will intercept the request. So I will go to the proxy here again. And do the same functionality again to capture the request here. Yeah. It's now working. It's capturing request from the emulator. Okay. So yeah, I will clear all the requests from here, and I will then show you my that emulator screen, and we will see again that it able to capture the request or not. Okay. So for that now, okay, yeah, this is the interface, and we will give any user ID to 10 or anything, and the password we will get ABC123 AB. We will give our test account test ACC1 test account one. Then I will get 10. Okay, I have to write it down that is 12 ABC123 and this test. Okay, and I will register it from here. Okay, the registration has been done. Next, then I have to means give my user ID here and try to log in. 23 and my user ID is 12, right? You see, I have logged into the account. Okay, and these are the so this is I think this is some post here, and these are the comments from various accounts like there is at the rate bad user, at the rate first account, at the rate 1 1. So these are the various accounts we have in this app. So what we can do here is I think we just we can just comment in that app. So yeah, I will write one comment hello, and I will send. Is it working or not? Okay, the request has been captured, but yeah. So for that, I have to stop my sharing screen and I will share my Kali Linux screen again. See, yeah. Now is the screen visible now, sir? Yeah. Okay, that's visible. Yeah. So see, uh, what we are trying to do here is we used that application to see the request is captured. Means the request get captured. So see the host here is from here. The post method means if you are using an app also, see web APIs are still in use. So in the first request we have VAPI user 3. See we filled username 12 ABC123 and our name. So in that response we get 201 okay and created. So you see in this request our user get created, and next we have second request when the login functionalities happen. Okay, yeah. So yeah, we get 200 in response, that is success, and the username with user ID 12 has been created. So yeah, when we get the comment request now, we are getting way more content than we are asking for. So see, this is nothing. This is our excessive data exposure. Means the API are exposing lot more data what the client legitimately needs. That's the thing is happening here. See, I'm trying to get the content of my comment, or specific page comment, means what other people's at typing, means pasting comments there. But instead of that, I am getting that who is posting. First of all, that ID is one, means someone is from ID1 is posting that his post ID, his device ID, means from where he is commenting on that picture with latitude and longitude, with comment, means what his comment are and what the username is. So see, we have a device ID, we have our flag in the device ID format. So yeah, this is the thing here. It means we are you are fetching the just means the detail of what comments has been made. But instead of that, we get way more way more resources, like who is he, from where he is commenting, like that. So this is nothing, this is but exposing data exposure, our A6. So no, now we will go come again to our slide. Yeah, yeah, we have this and okay, okay. So yeah, we have some points about how to prevent this type of attack. So yeah, never rely on client to filter data. Means here means whatever the client is requesting, the the server is giving them. So that's why never rely on client to filter data. So we have to review all API responses, not only that request, but we have to review all responses also. That means what the API is responding with, what type of data and all that things, and adapt them to match the API what consumers are really need. Means if API consumer needs to means need only a specific content of some resources, so he should only get that, not more than that. So next we have carefully defined schemas. We have to define schemas here, that at different levels APIs are working on different levels, different schemas. So in when the call has been made now, so it should not means fetch data from other schemas. So that's the thing here is, we know we means never forget about the error responses. We have proper schemas as well. They have to identify all type of sensitive data and personal, means PIA, personal identify information, justify for to use it. They have to enforce the responses checks, yeah, to prevent accidental leaks of data or expansion exceptions. And we will move further. Yeah. So next thing we have here is uh, lack of resources and rate limited. So see, against rate limitation has came. Means if a web application is not able to limit the rate, means how API calls should have been made, then it's a brute force attack. Clear DOS. See, we have DOS attacks here. So brute force dogs, all type of attack where we continuously send request packets to the server and ultimately it gets failed. So see, in A4, the API is not protected against an excessive numbers of calls or payload sizes. It means here now we can generate or design one attack in which we continuously send requests. So attacker can use this for DOS or denial of service attacks and authentication flaws like brute force attack. So you can see this in this picture, that there is a yellow PC is the target here, and the request has been made from every direction. So see, this is the thing here is. So now we will see. Okay, now we will see the lab, that how it should be done. Yeah. Okay. It's visible. Yeah. So for the next, yeah, we have API number 4. Okay. So I will go to the Postman here. I will close all the API 3 requests, and we will go to the API 4. See, lack of resources and rate limiting. So what we have here is, see, we believe OTPs, means one-time passwords, are a great way of authenticating users and are secure too, right? If implemented correctly. So the thing here is, the implementation had not been done correctly here. So that's why this flaws reside. So yeah, we have our first request. that is means mobile login. So if you are logging from mobile, so we give our mobile number basically, right? So yeah, I'm sending the request. Okay, yeah, it gets rejected because I have to configure my burp again. So yeah, okay. Now we will send this request again. Yeah, see, in this request, what is trying to hear is I'm giving one mobile number, and in the response, see, 4-digit OTP has been sent on the mobile number. So success true. So I'm giving correct mobile number. That's why I'm getting this message that okay, the 4-digit OTP has been sent to your mobile. So what's the second API here is? After that, we have to verify the OTP, right? So for that, here we have only OTP field, that is switch to the only 999, and I'm sending this. So yeah, so definitely that 999 is this four nines are not, it's not the correct OTP, right? That's why I'm getting success is equal to false here. And what is the cause of it? That the OTP is invalid here. So yeah, there's a catch. So what I'm trying to do here is I will send this to into the tab again, and I will brute force it. See, for that I will just let it be the sniper type of attack. Yeah, okay. Then I will go to the yeah below number with, and I will go to the numbers. Yeah. Then I will specify the list, the series of numbers that it should check. So in 4 digit OTPs, what's the possible combinations? Means what we can do here is from 999 to like 10,000. Like it's not 10,000, one number less than 10,000. That I start this attack from 1,000. Like it's a 4 digit number. This the means minimum 4 digit number and the highest 4 digit number, and I will increase by one. So that's why. So then I will initiate this attack. See what this do will there. See, it will go like this will go like trying each and every possible combination. I see here is trying 102 OTP, and I am getting in success is equal to false. So see, this will take huge amount of time. Brute forcing, yeah, brute forcing requires huge amount of time. This is basically the request size is 9,000 here. So yeah, for the sake of this webinar, I have solved this lab before. That's why I'm cutting, means I'm executing, I mean terminating this attack, and I will short the range here. Okay, because I know the correct OTP. That's why. So for that, if you are trying on a live system, so you have to be patient like that. Otherwise, we can't do anything. So for that now, I will specify here on the range of 1700 to, let's say I will go to the 1900 or like that. The OTP is between this. That's why. Now the attacks has been initiated, and see, all the status of 403 and the length is 269 like that. So let it completed. Let it be completed. Yeah, it's finished. So yeah, there are means way more requests that we can actually means see. So for that I will sort the length from here, and there's interesting thing I got. See, all the requests are here of length 269. All the requests are 269, but there's one single request that is the of length 280, and that OTP is 1872. That is the request, and what I have in response here is true. You see, so this is the process of OTP bypass. So if a web application does not have any type of rate limits, you can definitely do brute force attack on that OTP brute forcing, and yeah, you can log into that. So I got the key here. The thing is, I didn't know the what the right OTP is, so I did the brute force thing. So yeah, it gives me the control. So I got the key. So what the next thing we have in our, okay, like get details. The third API endpoint we have here is our third detail. So see, so I'm getting results that is false invalid token. So this is the token I got. So I will copy it from here. and I can paste it to here also. This authorization field here, I will empty this. Okay, the request has been captured now. Okay, yeah. See. So I will send it to the repeater, not sequence, repeater, and I will paste my key here and see. I got access. I got the access of John's account, and I got the flag as well. See, API4 flag. So yeah, this is the lab. This is how we do it. So I will go to my slide again. Yeah. So yeah, what we just did. So see, since rate limiting was not implemented, means how many times a API can be called is not implemented here. So and the second factor authentication mechanism. So that's why we bypassed it. So by launching a brute force attack, an OTP value, we got the right OTP and hence the user details also. So once the OTP is bypassed, we get the user details. So this is all about A5. No, A5 not. It is A4. It's all about lack of resources and rate limited. And next we have is broken function authorization. So in A1 we have broken object level authentication. Next we have broken function level authorization. So yeah, what the thing is now. Now you can see is the API relies on the client to use user level or admin level means APIs are appropriate. So now we will try to fetch details by logged into some other another users. That's all. So we will see the lab here again. Okay. Then I will come to the slide again to explain that lab. So I'm clearing all my previous requests from here. Okay. I will close all the requests from Postman also. And next we will go to the API 5. See, broken function level authorization. So what's the means comment here is you can register yourself as a user. Okay, I can register myself as a user. That's it, or is it there something more? Okay, so it's telling me that can you do something more? So it's also saying that I heard admin logins often but uses different route. So what do he mean by that? Okay, so let's do this. So see, there's one API endpoint to create user, like username, password, name, and addresses. So these are the endpoints with which now we can use user. So I'm sending. I have to exit from here. Okay, now it's clear. Yeah. Now I'm creating this account. Okay. So see, the account has been created with the username test user 2, name test user, address ABC, and the mobile number of this. And what I have got is ID is equal to 8. Okay. And the next API endpoint I have here is to get the details of that user. Okay. So it's not working as 50. Okay. I have to do one thing here normally. So see, there's a one more concept we can learn from this Postman here is where if you go to the test tab now, so we will see that what the code behind that API. See, so now here we have to observe this, that is how the authentication token is generated. That is with the username with one delimiter colon and the password. Yeah. So what we have in username is this, and we have a functionality called after that I mean, we are doing that BTOA. So this is nothing but a function to base 64 encoding. So we will use online tools to base 64 encode this. Means I'm trying to say here is I'm showing you that how to manually generate an authentication token from this lab. So I will copy the username and password field from here, and I will paste here, and I will delete all things, just our username and password. That way I have to check it again that the username is test user 2, okay, with colon, and that the password is test 123. Then we encode this value. Okay, so we get the base64 encoding of this string. And next we see. So for that I will have to first show that this in burp suite, that this is the first request of creating user, and this is the second request of getting the user details. So I will send it to the repeater, and I will paste that encoded thing here. See, what I'm trying to get is 200 okay, and my details. So yeah, I logged in. So what's after that? That's the question that came around in my mind. So I go again to that hint that what can I see? I can register myself, and I heard that admin logins can also be done from here, but they uses different route. So what we are trying to say is, see, this is the route, but this is the API endpoint. But this also suggesting that in which means folder and through which route the API endpoint is calling herself. Okay, so here what he is doing is, first we have forward slash. This is the first in Linux or anywhere. There is a root. Then we have vAPI folder. Then we have again, and in vAPI we have API 5 folder, or then we have user folder. And then we have number 3, and in number 3 I have the details of user 3 user. So now here we have to use our hacker mindset, that okay, normal users are okay, are getting, are placed here, not getting, then that means no, the user details of a normal user is placed in this folder, means in user. So what are the other folders then that can have the user details of admins? So we have to think about that. We can first that mean that endpoint. So for that now, uh, you need that mindsets, that what different endpoints can be used here. So now I will solve this lab just by eliminating the number 3 and that this front slash. Then I will go to the users field, means user folder. Can see just after sending the request, what I get here is I get the details of all users, means see. So in users folder now, the website is storing the data of all accounts. So here we have ID number 1, which is an admin user with its respective flag. So yeah, yeah, no, it's working. Okay. So yeah, what's the thing here is, zoom in a little bit. Okay. So yeah, I want you to see this picture. See, in that box, a normal user, normal functionality, a normal request response is happening. So here the administrator is here there with the role admin. So he's trying to fetch the details. See, the URLs are different here. So when a admin user is using the website now, he always go through the admin privileges. So here he is using the URL is get method, that is API. And this is the admin is there. So he's working under admin account, that, and then employee, then ID. So he get 200 in response to see check go, means the server is giving him, because he's admin now. So there is one person hacker out there, there is outside of that functionality, and he visited, he if he wants to check the payroll. So see the URL, check the URL is that is get API user, then is view payroll. Because why is this happening here is because this is a normal user and there is an admin user, that's why. So what we can bypass here is, if the normal user just replacing the user value to admin value, can he access the content? So if yes, then that thing is a broken function level authorization, that what we just did. So what he did is just changed that user, see, accessing admin API endpoint with an employee token. He have this normal employee token, but just by changing that user to admin, he can access the content which only an admin should access. That's why. So how we can prevent this type of attacks? So for that, do not rely on the client side to enforce admin access. So that's why, that's what I said. Deny all access by default. So by default, do not give access to anyone or anything, and only allow operation to users belonging to appropriate group and rule. So create proper groups and proper role, that if a person is working in under this group or under this role now, so that person should only be have access to that resources only. Then we have proper design and test authorization. So yeah, so what we did in the lab there is, we fetched the detail of another user by making an educated guess. See, I make a guess there, see, if a person is a normal person is using this user field, what a admin is using then. See, just why not just placing one text there, admin. So I got the flag, that's why. So we make an educated guess to a page which was not exposed directly to the normal user, but it didn't have any authorization checks. It doesn't have any authorization. It doesn't ask me any password or any passphrase like that key. Do verify first, then we should let you enter. So it doesn't do any type of authorization check to verify the privilege of the user. So that is all about A5. There is broken function level authorization. Okay. So, so see, next we have a mass assignment. Okay. So for that, I have to change my screen to my Kali Linux again. Okay. I will clear all the things from here. Okay. Yeah, is visible, right? Yeah. I will clear all the things from here, and yeah, I will delete the history from here also. Okay. Now it's clear. Now, I will go to the means API 6. I will clear from it also. Okay. Yeah. So it's API 6 mass assignment. So what he has here is, welcome to our store. Okay, we will give you credits if you behave nicely. So yeah, I'm getting credits. Okay, so there will be one credit fields in which the numbers is showing all that. So our credit management is super secure. Okay, so he's telling that his credit management is super secure. So now we'll test that. Okay, so see what we have here is, yeah, we have three fields with name, with username, and with passwords. Yeah, my burp is ready. Yeah, then I will send the request from here. Okay. Okay, I have to give fields first. Okay, I will give my name as test account. Okay, then I will give my username. Then I will give my password. Yeah. So now, for now, I'm creating account as a legitimate user. I'm not doing anything wrong right now. Means anything unethical. So that's why now I'm doing my just like that. I'm a normal person. I'm just checking the means how it is used, how it is creating user with the help of this web API and endpoint. So for that, I just created one simple thing and I've sent it. Okay. So yeah, ID number 17 is there. Our username is there. A name is there. Okay, got it. No problem. So next we have another endpoint. There is a fetch the details of the user. So yeah, I have intercepted that. Okay. For that again, I have authorization token for that. I need for that. So now I will go to the username and password. Same thing that I've done earlier. I will have to do that again. I will. On the same encryption is also used here. Or we can check it by that. Okay, by just going to the test. Okay, in the create user test. Okay, see, the same function is running here. It's API username password with the base 64 encoding thing. Yeah, so I will encode this again. Yeah, now I will get my authorization token. So I will manually place it right here. So I will send it to the repeater again, this new request, and I will manually place my token here. So see, this is so I'm getting one another means what can I say, another field in which I have credit, and the credit is zero. So by just logging into a particular website, now website is giving me credit. So if I behave nicely, my credit will increase. So yeah, so now we can do another thing. Now we will we use our mind that how can we increase this credit. So now we know the functionality that how is creating user and all that. So I will now do one thing. I will create another account with a credit 100. Means at first, means I am creating account with 100 credits. So what means how the website will handle, now we will see. So we will create another account, like just for the sake I am just replacing something, that it's a new account like that. So I will add 4 here, and I will add 4 here. So it's a new account now. So I will give myself a credit of like 10,000. So for that I have to generate my authorization token again na. So I'm doing it before. So yeah. Yeah, I'm encoding it. So yeah, I'm get my token here. So let's see. So yeah, user is created, and now I will give my authorization new authorization token here, and we will check that it's working or not. Now, otherwise I have to create one new account. Paste it here. See. So see, I created one new account with a credit field 10,000, and I'll get the flag. So this is how we can exploit this mass assignment thing. So I'm coming again to my slide to explain that how this thing works. Now it's showing okay. So see, what a mass assignment is. So an input validation flow. Yeah, you can notice that it is an input validation, means I'm inputting one field in the request body, and I'm getting that in the response. So an input validation flaw that allows attacker to perform advanced attack by manipulating payload data. So what I did there is I manipulate my request data with my request body. So that's why now I manipulate the payload. That's why I'm getting means I'm getting means I'm injecting malicious payloads, and I'm getting request. Means I'm getting the response like that. So what I have here is, see how a legit thing is used. This is Alice. So this she's a legit person. So she's using this endpoint, this post API users new with the username Alice and pass. So this is the normal thing. So what a malicious attacker is doing here is he is using the same means API endpoint, but with username and password he is using one more field, that is role is equal to admin, and he will get that admin access. So if this thing happens, so this comes under mass assignment attacks. So yeah, so what we did here is we identified that there is another parameter named credits. However, as per the design, there were no credit assigned while creating it user. Means when you are creating the user, another credit is not there. So we tried to forcefully assign credit by creating another parameter in the result. So that's what we did. We forcefully added that credit field into our request body, and we got the credit assigned, and hence with the flag. So how we can prevent it? So we can prevent automatically that do not automatically bind incoming data as internal objects. Means if a user, if a means a malicious injection has been done to the page, that if or something is trying to add things, that they just do not add it, or means just do not automatically bind it to the means queries. That's why. So and then explicitly define all the parameters and payloads you're expecting, but just don't explicitly define that if a role is admin just like that, so it's become true. That's why. So use the read only property set to true, means not executing should, or it should have been done on the read only mode. Then we have to use the precisely defined schema. Yeah, define. We have to define schemas. We see that in the previous slide. Then we have to separate the things with each other. So okay, so we have came to the next category, that is a security misconfiguration. So yeah, what this thing is. So this thing is a poor configuration of the API servers allows attacker to exploit them. Yeah. So how we can solve this? So I'm for again that I'm presenting my screen to my Linux. So yeah, I will cut it down from here, all those things. Yeah, I will clear the proxies also. Okay, so yeah, all clear. Yeah. Next, I will go to the API 7. That is security misconfiguration. Yeah. So what is trying to say this? Hey, it's an API, right? So are we expecting cross origin request? We just hope it works fine. Okay. So what we have here is in A7, we have our first API endpoint is to for creation of a user. So for that I have username, and for that I have password fields. So yeah, I will create one username and password. So for that, AST123, I'm just creating it. Okay, next we have, yeah. So yeah, the user has been created with an ID number 5. Okay, so the next yeah, the proxy, yeah, it gets intercepted. Absolutely fine. Yeah, it's working fine. Next API endpoint, we have to log in the user. Yeah, it gets false. Okay, so we will see. Okay, API authentication has been is required again. So for that, okay, I will copy this again, and we'll do base 64 from here again. And I will encode this. So this is my token, and I will add this. I will send it to the repeater first, and I will manually add my token here, and I will send the request. So see, this thing runs. Not only that, the in response, the server gives me my session ID, my cookie. So yeah, the success is true, and the message is that is a user logged in. And we have the next means API, that is a key, that is false and not. So yeah, so we will see from the burp soup. Yeah, that is forbidden. So I will send you to the repeater again. And for that, now for this lab I have to manually add my cookie here. That's all. So whatever I will do here is I will copy this, means not this, means I have to add manually that cookie, what my session ID here is. Then I will I have to copy that, this this my session ID. See, now I'm getting my auth key here from here. Okay, so I'm getting 200. Okay, means when you are trying to fetching your auth key now, so you have to give your session also. So in that default request, that field is not there. That's why I have to add it manually. So just the moment I give my session ID, so I got the auth key. So I will copy it from here. Okay, and then I will proceed. Okay, then I have that is another field, that is to user to log out. Okay, so now, so these things, one red flag has been raised, that first of all, no manual thing should be done with the request payloads. We see that we just saw that in my in our previous lab, that what happened if I manually add that credit value. So again, I can do here that I'm manually added my session IDs. That's why I'm getting the auth key here. So we have another thing called cross origin. There is CORS. So now for that, now I can do one more thing, that if I add my personal server here, what means how it can handle then. I got the flag here, but I'm explaining that what this thing is. See, this origin, this is a HTTP this is the HTTP header. This is the HTTP methods and this is the HTTP headers. So what a origin header is, so it basically tells that where the request has been made. Okay, so it indicates that what are the schemes, host and port names that caused the request, means from where the request has been caused. So just imagine that I'm hosting a phishing page on my live web server, and I'm giving it to you with this payload. So what can happen means this web page is able to work with this origin. That's why. So this is a private server. This hack server is nothing but it's a private server. So if I'm able to add things here, so yeah, if I manually add my virtual, means my server, my hacking server, so yeah, it will generally host phishing pages and I'll able to manipulate the security misconfiguration thing. Okay, so I will try to explain more in my slides. For that, I'm going to my slides again. Yeah. So what's happening here is, as a victim now, so if as a normal person created a user with usernames and passwords, logged in with the same credential, receive auth key. So this is a normal thing. So what happens here is, as an attacker, if a writes a CORS exploit for getting an auth key now, so just by means hosting that exploit in his private server, his or her private server, he can host that in your origin header. That's why. And then if the attacker send that link to the victim, the right after the it gets clicked, the session ID is hijacked. So that's why the thing here is, so the victim clicked on the exploit link, and the received that attacker received the server's misconfigured to trust any domain. So this is the important thing here is, that the server is trusting any domain as its origin header. That's why. So and it's sent back credential to that server only, and from where it has been caused. So how to prevent this type of attacks? So we can see that is, we have to establish repeatable hardening and patching process. I mean, we have to regularly available, we have to made patches for the thing. We have to automate locating configuration faults, means flaws, where it has been means from where it has been started. We have to disable unnecessary features. We have to restrict the administrative access also from all of them, and they have to define and enforce all outputs, including errors. So yeah, so this is all about, I can say that is a security misconfiguration. So yeah, next we have is injection. So yeah, injection consists of various attacks like SQL, NoSQL, LDAP, or OS, and other commands injections also. So yeah, we will see for this lab one SQL injection attacks. Okay, for that I have to go to again to my Kali screen. So yeah, it's visible. Okay, so see, this is what we have in API 8. So see, injection. So I think you won't get credential for this, so you can try to log in through. Okay, so for this now I don't have any type of credentials, but still I have these two fields, that is username and password. So yeah, just manually checked it. So yeah, I'm giving nothing, that's why I'm getting false. So what's the cause of it? That incorrect username and password. So yeah, I'm not giving anything, that's why. Okay, see, so I will repeat these steps again. See, I'm getting 403 forbidden as a response. So now I will do one thing. I will now do in SQL injections attacks. So that I have to create it all and I will add it to here only. Okay. Okay. It's working. Then I have to attack type. There is a battering ram. Now we have to switch the attack. Yeah. Then I will go to the payload. Here is okay. Then I will paste it. So see, this is the general SQL payloads. So this is the general thing. Just what I've said that these are the things that we use to test for SQL injection things. So SQL injection is a type of attack which comes under web application penetration testing. So this is just a small glimpse of it. That here what we can do here is, if you don't have credentials, but still with the help of SQL injection we can get login. That's the thing here is key thing. Here the means the query, the username payload, password is communicating with the database. So if we can manipulate, we can make fool of the database now. So he will get us the login. So these are the some basic general generic payloads that has been used here. Then I will untake it to stop restrict to encode themselves, and I will just start the tag. Yeah, we will see. So this is the what is trying to do here is it will manually placed himself in this fields only, and in response we get okay, this not works. Okay, this works. See, this payload works, and in response I get the auth key, and on the request is incorrect, false. Here false. See, this also worked. Okay, this also worked. So the the payloads that have worked now, so the auth key is same. So what I will do here is now I will copy this and I will go to the second get secret API. This is the next API. Then I will send it. Okay, I'm getting nothing, but I will check my proxy. It gets intercepted. Yeah, the API token is missing. That's why. So after bypassing that, I got my token without credentials. See, I have nothing. I have no usernames and I have no passwords. But with the power of SQL injection, I bypassed that and got the auth key with the respective flag. Now see, so I just logged into the admin users without admin credentials. So that's the power of SQL injection. So I'm coming to my slide again. Yeah, it's visible now. Okay. So see what's happening here is, since the authentication functionality now was not filtering user input, but once I'm inputting, it's not filtering, and the server was SQL language. So see the database here is used. So that's why I perform SQL injection here to get the got access to the admin credentials. So how to prevent it? There are some basic necessary steps. That never trust your API consumers, even they are internal. So never ever try to means left any field where a person can use means this type of manual SQL payloads. So strictly define all input data such as schemas, the types and string patterns are the same thing. That define all things and separate all of them. Then we have to validate, filter and sanitize all type of incoming data. Means we have to validate anything that has come to the payload, means that has come to the request body. Then we have define, limit and enforce API outputs to prevent data leaks, and then I have to limit all those things. So yeah, next we have thing another. Then we proceed to the next thing, that is improper asset management. So here is also an interesting but very easy thing. So what we have here is attacker find a non-production version of API. See, APIs now are built, are means are developing every day. So means if a company is using one API, so next month it got updated and the next version of API has been used. But what happened if the previous version of means APIs are not terminated, but if it's still in use, what happens? So say we will see now this, that what will happen. So see what the image is trying to say here is, Okay. This hacker here is uh, API v2 version 2, which is secured. We know that there is no, we cannot hack that API 2, which is secured because the firewall is placed here. So but we have if we have v2, that means there is version 2, that we must have version 1 also, which is not secured. Means after attack, na company built that firewall in the v2. But what happen if v2 is still in use? Means developers or the team forgot, misconfiguration has been happened, that API v1 now is still in use. So hacker will try to do that, bypass that request, that payload to v1, and get the content. So what that's we are trying to do here is, so we have one lab for that. So I will show you. Okay. Yeah, that's visible. Okay. So yeah, we have here is okay, where Postman. Okay. So we here we have is API 9. So what trying to say, improper asset management. So see, hey, they're saying that, hey, good news, we just launched our v2 API. So okay, so version 2 has been launched. So what about the version 1? So yeah, that's the thing here. We should always terminate older API versions as well. So we have API 2 and post login. So see, we have one username with its pin. So I'm sending the request, and the request has been intercepted here. So see, okay. So just check the response body, that we have rate limit, means remaining 4. Okay, so the rate limit has been posted here, has been done here. So I will send it to a repeater. I will change the pin to anything, just like 2123 4. Let's see. Okay, there the limit is decreased by number 1. So if I change that to 4, okay, in number 2. So after number 1, okay, at number 0 means I have nothing left to check here. Okay, if I send it again, now see, I have getting 500 internal server error. So see, now we cannot do brute force attacks. So cause we only means send 5 requests, and after that our accounts get logged, and we can't do anything. But that in version 2, right? What about the version 1? That's the thing here. So if version 2 is used, where the rate limiting has been introduced to us, but what about v1? V1 is not secured now. That's why company introduced v2. So yeah, now we will do this. See, now we'll get okay in v1. I just replaced a v2 v1. Now I'm getting 200 okay with anything. If I'm changing the means payload request, see, I'm getting 200 okay. So now the brute force can be done here. So I will send it to the intruder. Will clear of the payload. Okay, now I want to do this. I want to do means I want to do run a loop on this only. So I will stick to the sniper, and I will go to the numbers. Okay, so I have to provide it range. So again, this is a the original request is consist of 4 stars. That means 4 digit. So that means from 1000 to 9999. So this is a long process of brute forcing. I know I know how this labs works. So for that, now I will shorten the range. Okay. In payload, I will specify from 1500 or to 1700, and will increase the attack to number 1, and take the sure, okay, I will start the attack now. So yeah, let it be completed. That is at 50 201 requests is only there, and within that but the thing what we got, what I'm trying to say here is, at v2 now we have that x means x rate limiting thing, but at v1 we don't have anything like that. Means we can do the brute force again. So yeah, cause why this thing happening? Because the v1 is still in use, means still in the production server. That's why. So if I trying to see here is it's getting it's literally it's yeah, finished now. So at 201 request, it's still 200, it's still accepting us. So we will do that sorting again. We'll do to sort by length. Okay, see, all the lengths are 229, only one is 304 with the username, means the pin is 1655 and our flag is this. So see, so this is how we solved our lab, that is improper asset management. So I will come to the slide again. Yes, so see, the hacker is trying to access the server with v2, and it's get blocked by firewall, and in v1 there is no firewall. So what we did, that is change the v2 to v1 and gets what he wants. So yeah, so was this a really good news? So see, version 2 of API was launched with improved security mechanism. But the thing here is v1 was still left open. That's why. So what he's trying to say is it's still left open to invite hackers for a feast. That's why. So what we have here is how to prevent. So we have always up to date inventory to all API hosts. We have to limit the access. You have to limit the access to production data to anything. Means you have to implement additional controls such as API firewalls also are there. We have to properly retire older versions of API. Means you should always terminate the older versions. Next, we implement strict authentication, redirects, calls, and so forth. So these are all the attack terms. Okay. So in next, we have a last, means last attack, that is insufficient logging and monitoring. So this means this attack means this consists of no labs. That's why. So this is all the theory, that what's happened here is what I'm trying to say here is a proper logging and monitoring should be done. Means if you are doing anything now, the logs should have been generated to your systems. Means anything. Means if someone is visiting your website, someone is trying to enter means enter your username and password, proper logs should have been maintained. So what happens if not means proper logging monitoring is not maintained? So see, lack of proper logging and monitoring and alerting allows attacks and attackers go unnoticed. See, if you do not maintain logs, what will happen? You will not means calculate your means just like take an example that if you are we all study in school and colleges. So our teacher maintain one ident means what can see that presentation sheet, means what student are present on what day. So see, if the proper logging was not means not done by our teacher, so how can means he or she he will be calculated our marks at the end of our term? So that's the thing here. So proper logging monitoring should be done. So most of the time APIs are not configured for monitoring and logging. So when a attack has happened now, so we do not know that what type of attacks are going, and we should not we cannot do aftermath after that. Means we cannot investigate. So that's why proper logging and monitoring should have been done. So that is all about 810. There is no lab for that. So the yeah, since it's a design flaw, means we have to just maintain logs, we have to just create logs for that. Yeah, so how to prevent that? Logged fail attempts, denied access, means these are all the things that logged managed. Means if someone is try to enter passwords and usernames, if he or she gets failed, so this thing should have been maintained by log. So that's the thing of logs. Means what he or she is trying to do, or anywhere, that's the thing. So we have to ensure that logs are formatted so that other tool can consume as well. So yeah, the thing is a log the format of log now should have been the means universal one. Means there are various tools that have been available to scan and to interpret logs. So that's why logs should have been formatted in a proper format. Then we have to protect logs for like highly sensitive information. The logs are very sensitive in nature. That's why we have to protect logs. We have to include enough detail to identify hackers. So we should always try to add columns like time, means IP address, and thing means what are trying to do what, that thing. Basically, we have to means we add everything. Then we have to avoid having sensitive data in logs. that way, if means if you need the information debugging purposes, and then it should be provided to you. But we should have always avoided that username and password, like the means username and password should not been have stored in clear text in logs. So if you see, just assume that if logs gets breached, what happens, your username and password also means get out in clear form. So that's the issue. So we have to integrate with Seams. Means there are protocols. These are the tools that used for monitoring purposes, and other dashboard monitoring and alerting tools. So yeah, that is all about means all 10 type of attacks. There is still A10. So yeah, this is the end of our lab. Means we I have tried to means explain all attacks, all web API attacks that we have till now. So as the list gets means updated, it's changed, but the general performa is same. So yeah,